Welcome to Unacademy SN YouTube channel. Detailed solutions of daily practice problems, part 26. We have conceptual Mardan series on with PYQs of differential equations on 19th October, timings 7 p.m. to 10 p.m. I started complete course on engineering mathematics for ESE and GATE 2021 from 1st October, timings 10 a.m. to 12 p.m. daily. Another course, complete course on engineering mathematics for XE. I have started from 1st October, timings 8 a.m. to 9:30 a.m. daily. It is for engineering sciences. Detailed solutions of daily practice problems, part 26. I'll be discussing problems which I have shared on 11th October and 12th October on limits, continuity, differentiability of a function at a point. Now, let me start. Problem number 1. Limit x tends to 0, e power x minus e power minus x minus 2x by x minus sin x. When x is tending to 0, numerator is tending to 0, denominator is also tending to 0. Now we have to apply L'Hospital rule. Limit x tends to 0, e power x minus e power minus x minus 2x by x minus sin x. When x is tending to 0, numerator is tending to 0, denominator is tending to 0. It is 0 by 0 form. That's why we are going to apply L'Hospital rule. Limit x tends to 0. Differentiation of x minus sin x. Differentiation of x is 1. Differentiation of sin x is cos x. So 1 minus cos x. Differentiation of numerator. Differentiation of e power x is e power x. Differentiation of minus e power minus x is plus e power minus x. Differentiation of minus 2x is minus 2. When x is tending to 0, again numerator is in the form of 0, denominator is in the form of 0, 0 by 0 form. We have to apply L'Hospital rule. Limit x tends to 0. Differentiation of minus cos x is sin x. Differentiation of e power x is e power x. Differentiation of e power minus x is minus e power minus x. Differentiation of 2 is 0. Now, limit x tends to 0. E power x minus e power minus x by sin x. It is again 0 by 0 form. That's why you have to apply L'Hospital rule. Limit x tends to 0. Differentiation of sin x is cos x. Differentiation of e power x is e power x. Differentiation of minus e power minus x is plus e power minus x. When x is tending to 0, numerator is 1 plus 1 by 1. Finally, it is 2. The value of limit is 2. Next problem. Limit x tends to infinite. X square plus 2x minus 1 by 2x square minus 3x minus 2 whole power 2x plus 1 by 2x minus 1. Now, here x is tending to infinite. Limit x tends to infinite. X square plus 2x minus 1 by 2x square minus 3x minus 2 power 2x plus 1 by 2x minus 1. When x is tending to infinite, we have to take highest degree powers of x common. By taking x square common in the numerator, x square of 1 plus 2 by x minus 1 by x square by x square of 2 minus 3 by x minus 2 by x square power. Here, if you take x common, 2 plus 1 by x, 2 minus 1 by x. Now, you can cancel x and x. Here, x square and x square. Now, when x is tending to infinite, the limit is 1 by 2 whole power 1. Finally, 1 by 2. The value of limit is 1 by 2. Next problem, for which the function below is continuous at x equal to 1. The value of a for which the function below is continuous at x equal to 1. F of x is two x plus ax square when x less than or equal to 1. 4x plus 3 when x greater than 1. Now, the function is continuous at x equal to 1. Given that f of x is continuous at x equal to 1. Therefore, left hand limit equal to right hand limit equal to functional value at 1. When x is tending to 1 from left, when x is approaching 1 from left, 2x plus ax square, when x is tending to 1, it will become 2 plus a. When x is tending to 1 from right, 4 plus 1, 4 plus 3, 7. Now, the value of a is 7 minus 2, 5. So, a is equal to 5. So, in this problem, the value of a is 5. Next problem. Limit x tends to 0. 1 by x of square root of 1 plus x minus square root of 1 minus x. So here, to evaluate the value of limit, we have to apply rationalization. You have to multiply numerator and denominator with square root of 1 plus x plus square root of 1 minus x. Limit x tends to 0, 1 by x of square root of 1 plus x minus square root of 1 minus x. Now, multiplying numerator and denominator with square root of 1 plus x plus square root of 1 minus x, we get limit x tends to 0, 1 by x. Denominator is square root of 1 plus x plus square root of 1 minus x. In the numerator, 1 square root of 1 plus x whole square, 1 plus x minus square root of 1 minus x whole square, 1 minus x. Now continuation. Limit x tends to 0, 1 by x of, in the numerator, 1 plus x minus 1 plus x by square root of 1 plus x plus square root of 1 minus x. Limit x tends to 0. Numerator is 2x. Denominator is square root of 1 plus x plus square root of 1 minus x. If you cancel x and x, when x is tending to 0, numerator is 2. Denominator is also 2. 1 plus 1, 2. 2 by 2 is 1. The value of limit is 1 in this problem. So correct answer is second option. Next problem. Limit x tends to 1. 1 minus x power minus 1 by 3 by 1 minus x power minus 2 by 3. Limit x tends to 1. 1 minus x power minus 1 by 3 by 1 minus x power minus 2 by 3. Now, when x is tending to 1, numerator is tending to 0, denominator is also tending to 0. 0 by 0 form. That's why we are going to apply El Hospital rule. Limit x tends to 1. Differentiation of numerator is minus of minus 1 by 3. 1 by 3 into x power minus 1 by 3 minus 1 minus 4 by 3. Differentiation of denominator 2 by 3 into x power minus 2 by 3 minus 1 minus 5 by 3. Now, limit x tends to 1. 1 by 3 into 3 by 2 x power 5 by 3 by x power 4 by 3. When x is tending to 1, here 3 3 cancel. When x is tending to 1, the result is numerator is tending to 1, denominator is tending to 2, 1 by 2. The value of limit is 1 by 2. So correct answer is 1 by 2. Next problem. Limit x tends to 0. sin 2x plus a sin x by x cube equal to b, where b is finite, then the values of a and b limit x tends to 0, sin 2x plus a sin x by x cube equal to b, sin 2x plus a sin x by x cube equal to b, where b is finite. Observe here, when x is tending to 0, numerator is tending to 0, denominator is tending to 0, 0 by 0 form. That's why we have to apply L'Hospital rule. Limit x tends to 0. Differentiation of denominator is 3x cube, 3x square. Differentiation of denominator is 3x square. Differentiation of numerator is, differentiation of sin 2x is 2 cos 2x. Differentiation of a sin x is a cos x equal to b. When x is tending to 0, denominator is tending to 0, but numerator is in the form of 2 plus a. But given that b is finite, given that b is finite, it is possible only when numerator is also equal to 0. Numerator is also becomes 0. That's why 2 plus a should be 0. A must be equal to minus 2. When a equal to minus 2, then only numerator equal to 0, denominator is already 0, then 0 by 0 form will come. If 0 by 0 form comes, you are going to apply L'Hospital rule, then you can get the value of b as finite. That's why I am substituting a equal to minus 2 in the place of a here. Now, limit x tends to 0, 2 cos 2x minus 2 cos x by 3x square equal to b. It is in the form of 0 by 0. By applying L'Hospital rule, limit x tends to 0, minus 4 sin 2x plus 2 sin x by differentiation of 3x square is 6x equal to b. When x is tending to 0, numerator is tending to 0, denominator is also tending to 0. That's why we are applying L'Hospital rule. Limit x tends to 0. Differentiation of denominator is 6. Differentiation of numerator is minus 8 cos 2x. Differentiation of 2 sin x is 2 cos x equal to b. When x is tending to 0, numerator is minus 8 plus 2 by 6 equal to b. That implies b equal to minus 1. The value of a is minus 2. The value of b is minus 1. A equal to minus 2, b equal to minus 1. Now, if f of x equal to x plus 1 power cot x is continuous at x equal to 0, x plus 1 power cot x is continuous at x equal to 0, then f of 0 is. In this problem, given that the function is continuous at x equal to 0. F of x equal to x plus 1 power cot x. Given that f of x is continuous at x equal to 0. If the function is continuous at x equal to 0, definitely limit x tends to 0, f of x equal to f of 0. Now, limit x tends to 0, f of x is nothing but x plus 1 power cot x equal to f of 0. Yeah, we have to find out f of 0 with the help of this limit. Therefore, we can write f of 0 equal to limit x tends to 0 x plus 1 whole power cot x. It is in the form of 1 power infinite. It is in the form of 1 power infinite. Whenever limit is in the form of 1 power infinite, limit x tends to a. Suppose phi of x power psi of x. When limit is in the form of 1 power infinite, my discussion is about limit is in the form of 1 power infinite. So limit x tends to a phi of x power psi of x. Here phi of a is tending to 1, psi of a is tending to infinite. Then this limit can be written as e power limit x tends to a psi of x into phi of x minus 1. I am going to use this logic here. This approach here. F of 0 equal to, because it is in the form of 1 power infinite. Therefore, f of 0 equal to e power limit x tends to 0 cot x multiplied with x plus 1 minus 1. That is nothing but e power limit x tends to 0 cot x into x. That can be written as e power f of 0 equal to e power limit x tends to 0 x cot x. That can be written as e power limit x tends to 0 x by tan x. That is nothing but e power 1. That is e. Therefore, the value of f of 0 is e. So, correct answer is third option. Understood? Next problem. Limit the function f of x equal to 0 for x equal to 0. F of x equal to 0 for x equal to 0. 1 by 2 minus x in the interval 0 less than x less than 1 by 2, which is 1 by 2 at x equal to 1 by 2. Three by 2 minus x when 3 by 2 minus x for 1 by 2 less than x less than 1. One for x greater than or equal to 1. Now we have to examine option wise. F of x is right continuous at x equal to 0. Whether f of x is right continuous at x equal to 0 or not, we have to examine. Observe, functional value at 0 is 0. Right side of 0, when x is tending to 0 plus, you will get limit is 1 by 2 minus 0, 1 by 2. So 0 is different from 1 by 2. So the function is not right continuous at x equal to 0. This statement is false. First statement is false. Next, f of x is discontinuous at x equal to 1 by 2. F of x is discontinuous at x equal to 1 by 2. I am examining whether the function is continuous or not at x equal to 1 by 2. Observe. At x equal to 1 by 2, left hand limit at 1 by 2. 1 by 2 minus of 1 by 2, 0. Functional value at 1 by 2, 1 by 2. Right hand limit at 1 by 2. 3 minus 2 minus 1 by 2. That is 2 by 2, 1. Left hand limit is different from right hand limit is different from functional value at 1 by 2. So at x equal to 1 by 2, the function is discontinuous. So this statement is true. Second statement is true. F of x is continuous at x equal to 1. If you verify continuity at x equal to 1, when x tends to 1, 3 by 2 minus 1, that is 1 by 2, here 1, it is false. So all are true is also false. So correct answer is f of x is discontinuous at x equal to 1 by 2 is correct statement. Next problem. F of x is 3 plus x for x greater than or equal to 0. 3 minus x when x less than 0. 3 plus x when x greater than 0. 3 minus x when x less than 0. Now, if you examine right hand limit at x equal to 0, 3. Left hand limit 3. Functional value at 0, 3. Left hand limit equal to right hand limit equal to functional value. All are equal. Therefore, f of x is continuous at x equal to 0. Now, f dash x is differentiation of 3 plus x, 1. Differentiation of 3 minus x, minus 1. X greater than or equal to 0, x less than 0. Here, left hand derivative is minus 1. Right hand derivative is plus 1. Left hand derivative is not equal to right hand derivative. Therefore, f of x is not derivable at x equal to 0. The function is continuous at x equal to 0. but not derivable at x equal to 0. The function is continuous but not differentiable is the correct option. The function f of x equal to mod x plus 1 on the interval minus 2 comma 0. The function f of x equal to mod x plus 1 on the interval minus 2 comma 0. First option continuous and differentiable. Second option continuous on the interval but not differentiable at all points. Neither continuous nor differentiable but not continuous. Mod x plus 1 on the interval minus 2 comma 0. Mod x plus 1 observe here. If you look at the graph, clearly you can understand that the function is continuous. Graph is well connected. But if you look at the graph at minus 1, at minus 1 it is a sharp curve. That's why f of x is not differentiable at x equal to minus 1 belongs to the interval minus 2 comma 0. F of x is continuous but not differentiable. Within this interval at minus 1, the function is not differentiable. Therefore, correct option is continuous on the interval but not differentiable at all points. Second option is correct option. Continuous on the interval but not differentiable at all points. Because at x equal to minus 1, it is not derivable. Now, f of x is ax square plus 1 for x less than or equal to 1. F of x is ax square plus 1 when x less than or equal to 1. X square plus ax plus b when x greater than 1 is differentiable at x equal to 1. Then what are the values of a and b? Now the function is differentiable. Calculate f dash x. You will get differentiation of ax square 2ax when x less than or equal to 1. Differentiation of x square is 2x. Differentiation of ax is a. Differentiation of constant is 0 when x greater than 1. Observe here, left hand derivative when x is tending to 1, 2a. Right hand derivative when x is tending to 1, 2 plus a. If the function is differentiable, left hand derivative equal to right hand derivative, 2a equal to 2 plus a. So a equal to 2. When a function is differentiable, definitely the function is continuous. Left hand limit a plus 1. Right hand limit 1 plus a plus b. Left hand limit equal to right hand limit a plus 1 equal to a plus 1 plus b. Therefore, b equal to 0. B equal to 0, a equal to 2 is the correct answer. B equal to 0, a equal to 2. So, correct answer is third option. Understood? Unacademy presents iconic subscription for GATE and ESE. In iconic subscription, you have live classes, test series, unlimited practice, structured schedule, personal coach, study planner, experts guidance, ESE mains question and answer practice. In plus courses, we have DPPs, weekly monthly tests, doubt clearing sessions, live and interactive sessions, unlimited access by one subscription. To get plus subscription, pick a goal, GATE and ESE, use code KUR75 to get plus subscription for 1 year subscription, 2 year subscriptions, or iconic subscription. Use code KUR75. This is my profile on Unacademy Plus. Thank you.